This is sort of the challenge, and it's an international challenge, it's a national challenge, it's even a challenge in the state of California. A couple years ago, I was involved in a project that had to do with the translation of science for policy. We were working for the National Oceanic and Atmospheric Administration, also known by the acronym NOAA, and we studied this issue, we meaning myself and many, many other people from many other universities around the country, from the standpoint of translating science for decision making and actually seeing if the challenges of communicating complex, extremely complicated models that try to predict, not climate change, mind you, but just something as ordinary and everyday as climate variability, weather, drought, floods, El Nino and La Nina, these phenomena that meteorologists and atmospheric chemists study. Just to see if there was some way we could take all this complicated information and actually give it to policymakers in a useful form, and also so that the average person, particularly those whose jobs, whose professions, whose activities depend directly on weather, can actually use it. Farmers, utilities that produce electricity, that provide water supply, irrigation districts. Come to think of it, is there anything that doesn't depend on weather? Probably not, but there are some fields that certainly are more directly affected by it than others. And what we did is we discovered a lot of analogies in other fields in which there are efforts to try to create a translation of complex science into decisions. Not just so they could be understood, but so that the information could actually be used to engineer social changes, including changes in personal behavior. And we came up with a model, which I want to go over with you in a few moments, but also some text that goes with it that will help understand what we were trying to do. What we looked at, and what others have been looking at for quite some time, is how you can take things like climate information, forecasts about weather, about long-term climate trends, and translate them to be used by decision makers and the public. That's half the game, translating the information into a usable form. The other half was actually getting the information to be used so that it would transform social and individual behavior. We're not there yet, but this is the goal that scientists and policymakers have. And what this figure is supposed to show is the following. At the very tip, the bottom of this inverted pyramid, is dialogue among scientists, among policy analysts, among so-called experts who study weather, who study climate, who study the inputs into those factors, things like energy systems, climate science, and so forth. At the tip of this triangle, scientists and other knowledge producers actually share a common language and common sets of tools. They can talk to one another. You get a group of scientists at UCI together, and they can communicate fairly well. They might not use the identical vocabulary, but they talk in terms of probabilities and consequences and data and error, right? Statistical terminology that's fairly regularized. And they share among themselves, at least, a fairly high degree of certainty about what they know and what they don't know. They're fairly convinced about certain things. They're fairly convinced about their ability to predict things. That doesn't mean they're always right, but there is a good deal of certainty in what they know. You know, if you put this input into a system, you're going to get this output. Okay? The question is, are we going to put that much carbon dioxide in the environment? Well, that's up to you Okay? It's up to me. As findings and outcomes become increasingly different, however, as the political scientist, or the urban planner, or the sociologist, or the economist say, whoa, wait a minute. You want to know whether or not so much fossil fuel will actually be burned. You want to know, thus, how much methane and carbon dioxide will be produced, and whether or not that will actually be held in the atmosphere or absorbed by cities smartly and wisely planting new trees. Well, that's a little more problematic. That gets us into the area of social choices, social behaviors, political decisions, economically shaped decisions. If energy prices go up, maybe we'll find ways to use less of it. If energy prices remain fairly low, there's not a lot of economic incentive to conserve, and that'll also influence how people behave. Instead of, smartly buying Priuses, they'll buy, big gas-guzzling SUVs because gas remains cheap. It's amazing. You even look at the American economy today and you see these things almost on an annual basis. It's uncanny to me. It's like, well, gas prices went down 10 cents. I'm buying that SUV. Okay, exactly. So, a learning process has to occur for the information to be translated in the middle of the triangle to policymakers and to the public. So the users of forecasts and the producers of forecasts, they have to produce this information. If we continue to do X, Y, and Z, here are the things that are going to happen. And so you need to be aware of how your social choices affect the environment. And we can tell you if energy prices go down, approximately, in fact with a fairly high degree of certainty, approximately how much energy will be consumed. So that's the translating part. We want to get that information out to the public. We want to get it out to decision makers so they'll actually understand how science relates to social conditions and vice versa. But that's not really what we're trying to do. What we're really trying to do is to get policy change. That's transformation. And transformation involves scientists, natural scientists, physical scientists, engineers, and policymakers, and the public, and people who concern not just with science, but with ethics, with all kinds of moral and legal questions, to actually talk to one another, communicate with one another, and internalize what each of them is saying. Actually believe or share beliefs. You have to share the stage with ethics, politics, and other, in quotes, uncertain areas. Well, what's the right choice to make? Well, that's not quite a linear proposition. Should we urge developing countries to use less fossil fuel so that they won't be contributing to this climate change? Oh, yeah, that's right. I forgot. They're trying to develop and feed their populations. Oh, gosh, you have to spoil it for me. So I guess that means they're going to use a lot of energy. Well, that's okay. They can build dams. That doesn't produce greenhouse gases. Oh, wait a minute. Oh, yeah. That destroys river systems. Oh, gosh. Lots of uncertainties here. Lots of trade-offs between different sets of decisions. In order to achieve policy transformation, including changes in behavior, there has to be a way to span the boundaries between all of these ways of life. The spanning of the boundaries is what we call citizen science. It does not dictate what choices people will make. But what it does do is put you in the best position possible to make sure that when people make these individual and collective decisions, at least they'll have a pretty good idea what the consequences are, what the trade-offs are, and most importantly, what the likely impacts of their choices will be as feedback to a larger social and natural set of conditions. Does that make sense? It's not a question of dictating what you should do, but it's the idea that if people could know how they affect these variables, if the information could be translated and you could span the boundaries of scientists talking to social scientists, to planners, to non-governmental organizations, you can actually change your behavior in some fruitful way. You would, to come back to our earlier set of propositions, you could create, hopefully, a model of public policy, at least in the environmental realm, and this is a realm that crosses lots of areas. You could create a policy arena in which people could reasonably expect more. That is to say, more opportunity to reduce risks, more opportunity to better not just their present-day conditions, but what? The future. You could actually influence the future in a sense. But at the same time, you're not robbing people of their liberty or freedom in the sense of saying, this is what you must do and we're going to make you do it. You're saying, these are the choices, this is their impacts, this is what we know. If we talk to one another, we can create a transformation of society. It's very idealistic, but in fact, this is precisely the goal that climate scientists are struggling with today, as well as other policy analysts who are looking at global environmental issues. You could take this same model and put it in the world of medicine. And in fact, it has been put in the world of medicine and public health. Transformational objectives. Getting people to understand how their personal nutritional choices, lifestyles, hold certain risks or act to reduce certain risks. If you could span the boundaries between medicine and medical ethics and policy, you could eventually get people to understand their role in engineering certain social changes. I don't need to wear a helmet when I ride a motorcycle. Those are stupid. And besides, if I kill somebody, it's just me. Well, hold on there, partner. You know, if you die, somebody's got to clean up the mess. The costs are borne by society. Understand what the risks are, the likelihood that if you crash in a motorcycle, that matter a bicycle, without a helmet, it could be the difference between a concussion and a fracture of the skull. Big differences, okay? This is the kind of thing we do all the time. Smoking, drugs, alcohol, same types of things. Let me stop there. There's a lot to digest. Questions or comments? You kind of get the reasoning behind this? It's really spanning boundaries, trying to lead to transformation. Yeah.
So, talking about the whole nutrition piece, I mean, what we're facing in public health is that some populations don't have access.
Right.
So how does that carry over here? I mean, do we always have a choice to use less energy or electricity? I mean, for example, like right now, these lights in this classroom, like, they're on, but I can't shoot. Well, I guess
or do you have a choice not to buy a Prius? Come on, let's be reasonable. No.
So equitability of access to lower.
So here's the answer to your question. So this transformation, this spanning of boundaries has to take place in all elements of society. Some of the choices you can make individually. Some of the choices are going to have to be made on a larger policy level. Local levels, perhaps. State levels, more likely. California, this is exactly the calculus that the administration has tried to use in terms of things like AB 32. Well, we can sit around and wait for the federal government to do something. Or we can model appropriate expected outcomes. by actually using the best science we can muster, and then developing a set of policy objectives which will suggest certain outcomes, certain options for individuals as well as for collectives. Yes, some of those choices have to be made by governments, by collective organizations, by a larger group. But at least we know what the trade-offs are. We have some sense of clarity.
I'm reading some articles about a different sort of translation for policy, and it's sort of translating qualitative experiential knowledge into science for policy.
Oh, yeah.
And what can you say about that?
How does this fit into that? Yeah, so what this doesn't show you yet, but we're going to get into in a moment, is this still assumes that scientists have this repository of knowledge. And they're going to tell the policymakers and the public what to do, and then the policymakers and the public are going to share their ethical experience and their policy and their political knowledge. But that's not the whole truth. In this transformation process, the public may have local and indigenous experiences and knowledge that the expert scientists also need to hear about, so that they can better develop a science that is attuned to societal needs. We'll see an example of that in a moment. But yes, you're exactly right. It's two-way, it's iterative, which means it goes through various phases of development. Like thought, right?
Does that mean that scientists should be advocates for certain policy directions? You know, it seems like they would undersell their potential to move something forward if it was just about disclosing information.
Right. That's a great question. And I think what this model, or at least what we think this model connotes, is that indeed scientists are advocates for their information. But it's an advocate that's based on a sensitivity to the other ways of life. So instead of kind of marching into a room and saying, I have these facts and figures here that show if we don't stop burning fossil fuels, these horrible things will happen. Instead, it's, I have data here that show we're going to initiate changes in the climate. What I need to understand from you is what are some feasible things we could go back to our laboratories and to our computers and study, so that we could come up with some useful information to help you take what we know in a usable form that you can then go and make changes. Does that make sense? It's a sensitivity to these other, it's a cross-fertilization of ideas. The policymakers enriched by the scientists. The scientist comes in not with just a model. Remember the loading dock? It's not just here's some science. It's I've come in with some facts. Very comfortable with these. Now you as a policymaker have to struggle with this. What else do you need to know from me that can help you use my knowledge and information? So it's a very good point. We're going to come back to that.
Well, and I think it's also a bit confusing because different scientists that study different things have such vastly different priorities.
Yes.
Like in undergrad, I worked at a cancer research lab, and I don't think I've ever been in a building that seemed like such an environmental catastrophe. They have negative airflow, so the whole thing uses a ton of CO2.
Right.
And like in the interest of sterility, they have to throw away hundreds of plastic pipette tips every day.
Tons of waste.
It's just, and then you have those scientists saying, well, we're doing this for this cause. Whereas a bunch of other scientists could come in and say, oh my gosh, this building should not even exist.
Yeah, we do this all the time, and one of the things we talked about when we did this research, and others have talked about, how much CO2 is generated by policymakers and scientists flying around the world to conferences to discuss the CO2 problem. I mean, it's a really serious issue. I mean, in all seriousness, if we understand that the solution is causing the problem, then it makes us think about alternative ways of communicating what we know and how we meet, maybe more virtual meetings, still using electricity to, use Skype PlaceBased conferences, but my suspicion is probably a lot less than flying jumbo jets transcontinentally. That's a very good point. I mean, this gets back to the ability of the scientist or analyst to draw on the other experiences to see things that may be obvious to others, but are not very obvious to the scientist.
So I'm sure that this would be a fairly unpopular model in certain cases, but like who is really initiating this translation? Is it the policymakers seeking out the scientists, vice versa, the community demanding information?
Yeah, that's a good question. Sometimes it's all of those, sometimes it's only one of those, sometimes, unfortunately, it's none of those, and somebody has to kind of initiate it for them. Let's push on a little bit to take a look at these sets of issues. So, we're in the realm of transformation now, citizen science. A definition. This comes from John Gibbons, who used to be the director of an agency that Congress in its wisdom abolished, called the Office of Technology Assessment. John Gibbons was the last director of LTA. And Sheila Jasanoff, who is a sociologist who studies the culture of science. We talked about Jasanoff some weeks ago in reference to crossing boundaries between science and social science. And they define citizen science as a science-society collaboration. So it's not one talking to the other, it's both talking to each other. And a production of policy-specific knowledge. So it's not just coming up with your computer program showing all your data, okay? It's coming up with policy-specific knowledge designed to solve problems. Now that is a big challenge for the scientist who on the one hand wants to advocate something, but may be reluctant to tailor findings to a policy audience. You know, you're used to talking to other academics. You're used to going to a professional academic conference and just talking with other scholars who think like you do, and then blasting the politicians for not doing what your data suggests. Well, if you want to be an advocate, that means you have to be in a position to exchange information on a level that makes usable sense. It mobilizes, and this ties some of your questions together, I hope, it mobilizes academic and pragmatic. And pragmatic means knowledge that you and I might have. You work in the hospital, you work in the medical center, you may not be a physician, but you know when there's a lot of waste and a lot of trash and a lot of wrong use of HVAC systems going on. Okay, that's pragmatic knowledge. And experience to produce better solutions to environmental problems, health problems, and technologically related problems and issues. So all this indigenous knowledge, local knowledge, personal knowledge, whatever you want to call it, this is what you're using. Think of this in terms of research many of you are doing. Policy analysts and scientists are trying to figure out how to better dispose of or recycle toxic materials in the environment. So you go out and you ask the scientists what the toxicity of these various substances are. That's great. But now we have to know how the public manages these things on their own and what they understand or don't understand about these things. And whether or not they might even have some ideas for how to better reuse this material or exchange it or turn it in at the end of its life. Okay? It grounds broad theoretical scientific assumptions, very key point here, in a place-based setting. This is where problems have to be solved. You don't solve problems in a generic sense. You don't solve climate problems or health problems in a laboratory or in an office somewhere. You solve them at a community level, at a watershed level, at an airshed level, at a biological reserve level. Okay? This is where you solve problems. It's place-based knowledge. By the way, this is a real contribution to this discussion of citizen science that comes to us from a number of disciplines, including geography and urban planning. The idea of place-based and spatial thinking about policy problems. Think of any environmental problem or health problem that isn't place-based. Challenge it. Think about it. How could you divorce these things from real science? And it promotes longer-term thinking about impacts and responsibilities, including our individual responsibilities to future generations. So the idea here is to take what we learn and apply it to our lives, but we can't apply it to our lives if A, the scientists can't translate it, and B, the experts don't listen to us and try to understand our constraints. Yes, you talk about conserving energy. Yes, you talk about generating less waste. How do you do that when you're also struggling at a local community level to feed a growing population? These are things that have to be reconciled. And more importantly, as we've been talking about this, it emphasizes experimentation and two-way communication. Really, you could say multi-way communication, but two-way meaning between the scientists and the policymakers and the public. Science is not a loading dock. Here are the facts. We're going to unload them for you. You guys take it and use it. Figure it out. That's not our problem. We're scientists. It's a circuitous process. And it is an iterative process, which means it has to go through phases of refinement. We call it citizen science because it is science more broadly construed as a form of scientific literacy. This, by the way, was one of the goals of the Office of Technology Assessment before it was abolished some years ago. The idea behind the Office of Technology Assessment was to provide a means to educate lay people, because they produced reports that could be read by anyone, and politicians, in particular Congress, to understand how prospective changes in technology could affect public policy. To actually figure these things out before the changes actually came about. OTA, Office of Technology Assessment, did some of the earliest studies, for example, on the social impact of the internet, on the social impact of the revolution in personal communications, and how this would have policy implications. So this is kind of what we're going. Questions?
Well, I feel like previous policy or policy done by other polities has a big effect on this, because polities look around to see what other polities are doing on an issue if they're uncertain. So, like, one of the things you were saying was having a country that's trying to balance feeding its population with creating waste. And one solution to that are genetically modified crops that might use less nitrogen fertilizer, but because the EU has outlawed them, a lot of developing nations presume it's because they are dangerous, not because they might be dangerous, and will probably take worse trade-offs.
That's right. And that's a really good point, because one of the things that lurks behind this kind of citizen science is the notion that every risk is potentially a trade-off. And while no trade-offs are ideal, that's why we call them trade-offs, there are some trade-offs that are marginally better than others, depending on your social setting. Is genetically engineered food worth the risk in a society that finds itself having very little water, very few options for inputs into the soil that could be used to produce large yields of food? Maybe it's a acceptable risk. You don't know unless as an agronomist you actually talk to people within these communities in these developing countries and find out what they see as the relative benefits of a green revolution technology.
Yeah.
So we have to be careful.
Well, because a lot of these communities will drink untreated surface water, and if that has nitrogen fertilizers
That's
in it,
right.
it's a lot more dangerous than any genetically
You bet.
modified crops.
You bet. That's exactly right. I mean, that's a known hazard that has all kinds of, implications, as opposed to a genetically engineered food, which may have certain implications down the road, but likely to be a lot less in terms of their palpable impact on human health than the fertilizer, nitrogens and phosphorus going into the water supply.
Well, in fact, that's not a good, well, there's more aspects about this example anyway, because,
Yeah.
I mean, these genetical, how do we call it,
Genetic engineered.
engineered.
Yeah.
I mean, you kind of depend on like big companies, mostly based in the States.
That's right.
And have to test it, you have to like buy the seed, like
Yeah.
the seeds like every year. So there's more about it than just like the environment.
And you raise another very important implication, Jacob, which needs to be probably called out separately. One of the things that this body of research has identified as another challenge is that much of what we call science, or much of what really is science, is proprietary. So for example, and this is true in the field of weather and climate, as well as in nutrition, as well as in agriculture, as well as in medicine. Lots of scientific studies, this gets back to some of the points that Beryl Radin made about policy analysis, are part of a marketplace. If Monsanto is doing the research about the harm or the lack thereof of a certain biotechnological process, it should make us suspicious as to whether or not it's been adequately peer-reviewed and if it's something that there's a broad consensus about. On the other hand, they may have more resources than governments to do the research. And so you're really sort of vulnerable to the problem of who's originating the knowledge. And what this model would suggest is that you want to ensure that any expert science is open and transparent, and that the most critical science for decisions is not proprietary. And if it is proprietary, that the barriers be broken down to make it non-proprietary. So at least the risk factors can be disseminated broadly. That's easy to say. It's a heck of a lot more difficult to achieve in a society where powerful interests through the subsystem of policy making oftentimes control the knowledge base. It's an important issue.
So just from my own experience, because I've worked on a project with inter-transdiscipline, it's really difficult just to get the subsystem of science to work together. And I've kind of been going around and talking to different departments and different people just unofficially to figure out where to work on my research. My strength is really in bringing people together. And I've heard so many times, from stats people or chemistry people, oh, that has nothing to do with what I do. Or that, it's sort of like they have never recognized or given credit or accolades for being an expert in the translation piece. And I think there's such a gap even within science. Even here at our own university, you actually seem like the most open-minded with the notion of bringing together ideas.
So the question is, what are the barriers to this? That's really the question, isn't it? We've talked about proprietary issues.
Well, and also, just the translator has to be able to sell themselves and sell the information. So it's really about creating experts who can speak a lot of languages in terms of industry or science.
So let me mention a couple other very practical barriers since you talked about universities. In studying this, this is one of the things we considered. So point me to the Department of Translational Science.
The ICTS is not a department.
We don't have it.
No.
Okay?
And the ICTS is very clinical.
Right. But the point is that academics get rewarded for becoming expert in relatively specific narrow fields. We don't send out stuff we write to the public and ask them to peer review it. You get the picture. It's the same in virtually any field. So one of the challenges is the compartmentalization or the stovepiping of academic life. That makes scientific translation very difficult. It is precisely the reason why we establish centers of translation. One of the solutions that has been prescribed is developing a reward system for interdisciplinary or really cross-disciplinary research. Social ecology as an entity, so please don't ask me to define what it is. No, I'm just kidding. Social ecology, at least as it originated in places like UCI, was actually seen as a means of creating a cross-disciplinary set of fields. You still have separate departments, you still have disciplinary bases for people's academic homes, but the idea is that it would be engaged research in the sense that we're talking about here. That's an objective, that's a goal. We don't always meet it. Universities are not perfect at it, but you know, either are policymakers, right? Government is similarly compartmentalized. Federal agents, we're going to come back to this momentarily, federal agencies and regions don't talk to one another. Think back to AB 32. California said we can't wait for the federal government to come up with a solution. We're going to come up with it on a place-based basis. Other states, other regions around the world have followed suit. We will innovate by diffusing knowledge across political boundaries. You don't need to wait for Washington to figure out what to do. We can do it ourselves. In fact, maybe we should. So there's lots of barriers. Push on just a little bit here. So here's an example of what has partly resulted from this work. Congress told NOAA to go out and create a program that would get good science into the hands of decision makers and the public, broadly defined. So decision makers mean not just other federal agencies, but states, local governments, non-governmental organizations, and so forth. And we call it the Regional Integrated Sciences and Assessments, plural, program, Risa. And this is a program that's designed to take climate information, which is an enormous body of information. Some of it has to do with weather. Some of it has to do with longer-term climatic trends. Some of it has to do with monitoring drought, or soil moisture, or storm systems, or a whole bunch of data, tides, you name it. And then basically carving up the United States, and you'll notice not the entire United States yet is bought into this, but it's a decentralized program. All NOAA does is offer a platform of knowledge and the opportunity to interact with they and other agencies. It's up to states to come together in appropriate ways and figure out how they want to use this information. And so you've got a consortium. California has joined with Nevada. Arizona and New Mexico are working together. The Intermountain Western states, and you can tell by their titles, the names they've chosen for themselves, something about the priorities. In the case of the Intermountain West, it's all about water. Always has been, but it's really all about water for these guys. For the Mid-South, it's about climate impacts planning program. It's about planning. It really is an urban planning emphasis. In the Northeast, it's about climate risk. They're already talking about sea level rise and climate changes as affecting their economies in critical ways. The idea is that you have team members primarily based at universities, though some are based at government research facilities or nonprofit organizations, or even private sector entities. You have team members from all kinds of institutions and all kinds of scientists. And their research focuses on applications. That's the key thing here. It's about taking their science and applying it to specific problems. The management of fisheries. We reminded again of fisheries, Redondo Beach, right? Don't know what's causing it, but it's not something good. That's for darn sure. Water, wildfire, agriculture. We work with citizens groups as well as with agencies on climate-related issues, broadly defined. So just about anything can be a climate issue. Flood, drought, weather variability. The program also supports research into climate-sensitive health issues, the spread of communicable diseases or the spread of insect-borne diseases as weather systems change, climate changes. And coastal restoration has become a real important issue because that's very definitely affected by weather and long-term climate. The idea here is that scientists, policymakers, including non-governmental groups, exchange information. The idea of Risa is not just taking a bunch of science and shoving it out there, but asking these local and state place-based entities, what kind of science do you need? What sorts of things would you like us to model? What kinds of questions do you need answered? In Colorado, they don't worry about flood risk as much as they worry about no water, okay? It's a relative thing, obviously, the water does rain until it rains. Okay. Coastal states, they're worried about sea level rise, they're worried about estuarine risks. They're also worried significantly about agriculture as we are in the West, and forestry issues. So this is one example of this. It's an example that was encouraged by Congress, who basically gave the charge to NOAA, said, work with communities and states, let them decide to organize themselves as part of this network, part of the citizen science network, and then go for it, see what happens. Questions or comments about this? It's still in a fairly high degree of infancy. It's only been around since really the beginning of the decade, and it's being refined. One of the proposals out there is to take this model and to create, you all know what the National Weather Service is? To create a national climate service. That's not going down very well in Congress right now. But that's one of the proposals that's come out of these activities. We need a national agency that can help predict long-term climate changes so that we can begin addressing questions in the form of just the same way the Weather Service does it. You know, good, useful information. Of course, we know climate change is just a, you know, hypothesis, so we probably need that. Anyway, okay, let's get ahead of myself. Questions about this? Comments? So this is translational, and it's meant to be transformative science. Let's turn to the public participation dimension of this and related problems. So we're talking about science citizenship. The idea is that you'll actually span boundaries between various fields, various disciplines, various ways of life. We still have to find a way to involve the public directly. This is a challenge for regional integrated sciences and assessments, and it's also a challenge for public policy generally, as we've seen. What is public participation? Well, it's variously defined. Often it's defined in various ways, as Ellis notes, and others, depending on how keen you are about public participation, how much you really want it to take place. let me suggest there are two basic sort of approaches or paradigms. One is a passive approach, which says what we want in terms of participation is we want to be able to monitor what the public thinks. We want their acquiescence. We want to know their opposition, potentially or otherwise, to some policy through an expression of favorable or unfavorable opinion. We can do this by polling people. We can ask them what they want or what they don't want. We can even go a little bit beyond that and have focus groups come together and ask them what sorts of healthcare options they might like. And we can do this in various places, again, place-based, so that we monitor what people think about problems and solutions. It's currently done in many policy areas. And it faces a lot of challenges, as you know. It's ineffective, critics charge, in creating any sense of community. Because there really isn't anything vested in a policy. All you're doing is asking people to react to something. What do you think? Do you like it? Do you not like it? And it doesn't really give the public any sense of policy ownership. All you're doing is taking this information back and creating changes. Which brings me to the proactive approach, which is a more dynamic approach that's being proposed as a way of addressing many of these challenges. An active role for the public in actually making decisions through legally sanctioned and unconventional mechanisms. Mechanisms that don't often have a clear mandate in existing institutional arrangements. Advisory boards or citizen oversight bodies could be an example. This mechanism, this approach, has been attempted in many environmental and community health and development policies. I'll make a blanket statement and then we'll talk about it and let you all challenge this. It can be effective, but it requires a lot of thought in program design. How much power and authority do you actually give these oversight bodies or advisory boards to make decisions? This is beyond street-level bureaucracy. This is asking people who are not part of the organization at all. They're not on anyone's payroll. Okay? They don't really have a direct stake in the policy implementation organization. But we're asking them to advise or to oversee and to recommend and to suggest changes. What do you think? Don't buy that? It's a good thing? Do you think that's a good thing? How many of you would like to have an advisory board telling you what you have to do in your jobs?
That would be the advisory board for somebody else.
The advisory board for somebody else, it's okay.
I had to create, for our study, 15 neighborhood advisory boards. And we did this whole qualitative interview study. And everyone has a different reason for being there. And it's a good thing to be able to convey those different reasons. The difficulty becomes, managing for them, what is their role? If you can't really take what they give you and do anything about it, you say, oh, what do you think? And you evaluate and you report it back, but it doesn't really affect how things are done.
Can that create ill will?
Yes.
If you take what they do and just ignore it? Thank you very much.
Right.
Have some coffee.
Or, I, of course, try to do something with it.
Yeah.
But yeah, you end up not necessarily being able to integrate it, so then they feel like they're wasting their time.
Right.
But for different people, it's different. You get people who just like being on those things, so it doesn't become how they view themselves.
Which also gets into a number of very sociological kinds of issues, like, is this really accessible to anyone? Or are there certain people that are more likely to be accessible to this kind of activity because they have the time, the inclination, the opportunity? Not everyone really has an opportunity to engage in this sort of thing. You do have to be explicit about what the objectives are and how much authority is being shared. It also applies some things about the culture of an organization and whether it has the propensity to actually, not just to listen, but actually has the capacity to take what it's hearing and change the decision, right? And that's not often an easy thing to do. Sometimes you have a mandate. Congress tells you one thing, Sacramento tells you one thing, Santa Ana tells you one thing, now the public is telling you something else. How do you reconcile those two questions? So let's take a little deeper look at this, some of the challenges. A lot of barriers to this. We need to be a little more explicit about what some of these barriers are. This is not surprising, but it is a point I think Ellis makes quite elegantly in talking about some of the ethical challenges of participation as we move toward the future of public policy and some of the challenges that face governments across the world. Many agencies that are responsible for very critical issues. And it's interesting, it seems like the very issues that are most sensitive to most people are precisely the ones that lead to greater secrecy, an ethos of secrecy. Closed processes of deliberation. So can you tell us what you found about the contamination of the groundwater? Well, we're not really ready to release that yet. Please, don't quote. Are you from the Orange County? Oh, I can't talk to you. I'm very sorry. We're continuing our studies, and I don't want to create any panic, and I don't want to mislead you, so I'm going to have to ask you to please not ask me any questions. We have to continue to do our methodical study, and we'll announce our findings
You sound welcome.
soon. Thank you. Yeah. Well, I used to work at Oak Ridge National Laboratory, and we were trained well on this. Hierarchical command and control. Again, public health agencies, often hierarchical. Environmental agencies, likewise. Regulatory agencies of government, by necessity, because they enforce regulations, tend to be like police. They're hierarchical. There's not a lot of room for discretion. Remember we talked about regulation and discretion. The irony is, because they lack discretion, there's a lot of certainty in what they can do, but there's also less leeway in how they can communicate to you. I'm sorry, we can't issue a ruling yet. We're still doing our study. Can't tell you much more than that. Many agencies lack the staff with the experience and the training and, yes, the inclination to embrace or guide input. We find this to be true to a lot of public works agencies. How many of you ever had to deal with Caltrans on a community-based issue? Is it challenging, to say the least? Why is that? It's so hard to deal with agencies that have a mandate to build things. We had a public hearing.
Money?
Money. Yeah, go ahead and elaborate on that a little bit.
Well, if you're looking at like Caltrans building, I think it could eliminate anything that comes with development, any time that you're taking to take in public comment is going to make the process a lot longer, therefore making the bottom line a lot more expensive.
Yeah. The more participation you have, the longer you draw out the process of a decision, the more expensive it becomes. They're held accountable for their budget, right? Mm-hmm. So it creates a real paradox. Again, I'm trying to get you to realize it's not a clear linear choice. It's a trade-off. And in fact, this is a real challenge. And we're going to come back to that at the end in just a few moments. It's also hard to convince agencies that while participation may slow decision making, it may make decisions more durable and more just. But again, it's a may. It's not certain that that's going to result. It's just, yeah, it may make things more acceptable until the next time somebody objects to something we do, and then it slows the process down again and again and again. So it's a real dilemma. What you almost have to do, without getting too far ahead of myself, is you almost have to change the whole conception of a bureaucracy and what its mandate is and how it interacts with the public. And I'll just tell you right now, this is a long-term challenge in organizational design. Nobody has come up with the way of solving this dilemma.
Well, another problem is the methods by which agencies are kind of forced to solve problems. Like at the water district, a lot of the time the only way to solve the groundwater issue is to bring a lawsuit against somebody, at which point it suddenly becomes illegal to release a lot of the information, and there's a lot more constraints than if we were allowed to pass laws or legislation, but we're not.
Yeah, and that's the design of the law, because there's a kind of a fiduciary responsibility to carrying out, to comply with a regulatory regime, and if you don't do it, you actually subject yourself to a greater degree of liability. That's right. Yeah, so it's really difficult. It's not an easy kind of thing to do. And then I'll just say this, perhaps obvious, but I think it needs to be articulated. Defining the public as a challenge. Think of this in terms of issues involving environmental justice. Many of us deal or will deal with questions of environmental fairness, exposure to risk, exposure to toxic materials, vulnerable populations. People respond to risks in different ways. Some people are more vulnerable in terms of their exposures to those risks. Do we define participants as those subject to economic or other impacts, or do we just take a community and draw a circle and say everybody in this circle is the public? Oh, I'm sorry, you live downwind of the nuclear plant, but you're too far away to be considered part of the affected community, so we don't really need your opinion. Anyway, should participation be limited to elected officials, as it often is? What often is called public participation is actually just a federal agency having the mayor or the county commissioner, right, or the public information officer again. Or maybe even we'll extend it to the leaders of various non-governmental organizations who are activists, who are very vocal, but may not really be the public, right? So this is a real challenge. Nobody's quite sure how to figure this one.
Well, in a way, it could be considered more democratic because technically more people probably voted for the mayor than would be able to attend the meeting anyways.
This is true. Assuming, in fact, they did vote for the mayor, and assuming that the voter turnout was, but your point is well taken. I mean, there's no easy way to do this, and at some level you got to kind of call it as you see it. Maybe a more effective way of deciding who should be a part of this than just to choose someone random. So you got to choose someone.
And it's hard to say that the mayor or whoever would be representing the people who voted for them accurately. But also, I mean, I wonder with issues like Lulu's, I mean, with landfill siting and you know, these sorts of things, if all of these publics are engaged and a part of the decision-making process, nobody is going to say, sure, you know, we'll have it come into our domain, that's fine. So then where does it go? I mean, we have this fully engaged, in an ideal world, we have a fully engaged set of communities. Nobody's going to take it, so where do we put it?
Right. There is a point at which you could end up with a total gridlock of any unwanted decision. No, somebody is not going to want something, right? Somebody's not going to want the landfill. Somebody's not going to want the nuclear power plant. Someone's not going to want the Walmart. Do we give those somebodies a veto? Or do we introduce certain criteria, prescriptive criteria, both in terms of the process and in terms of a desirable outcome, which assumes we can agree on those criteria, and then those criteria will rule the day. Not everyone will be happy with the outcome, but at least everybody will understand that they had their day in court, so to speak. That's kind of where we're at with these questions. Still doesn't really solve the problem because you're always going to have somebody that doesn't want it. So how do you say the process was fair if you ended up with something that somebody didn't want?
Or that they didn't know would cause as much risk as it does.
They didn't know. So it also suggests that you have to be adaptive and a solution can be revisited. We talked about adaptiveness before, adaptive organizations.
I mean, all of this, then, it's such a no-brainer then to come out of the gate saying, no matter what, there's going to be problems. And yet, like we talked about, politicians or certain leaders are so against that sort of humility. And I wonder if the public, instead of having an outcry, would be relieved to say, okay, well, at least now they're being honest, and we really don't.
So let me kind of come to a bottom line here. What we're really talking about is taking this paradigm and somehow linking it to citizen science. Again, it's not an ideal solution, but presumably the more we know and the more literate we are, the better we'll be at our participation and our input. Now that's a very high bar to set, but I would submit to you what's the option? What's our option? If we continue to go on a course that says, trust us, we know what's best for you, and we're experts, then we'll continue to deal with this quandary of people demanding less risk, more benefit, and yet no restrictions or few restrictions on their liberty, particularly those that are unreasonable. And so we're kind of left with this. It's fusing the citizen science and the participation. It's not a solution, but it's maybe an avenue toward a solution. So let's kind of finish up here. So some keys to participation and policy success. And this, I think, is where they come together. There have been a number of studies done over the last 20 years or thereabouts that look at how you can kind of make participation successful by taking what we know about participation generally and combining it with what we know about this transformational science. And let me suggest these 4 things as some of the keys that have been identified in the literatures that have been done on these problems. Some of this comes out of very specific case study literature on public participation and public policy. Some of it comes about through more systematic surveys of public attitudes and public values about certain kinds of problems and issues. And all 4 of these things really aren't outcome solutions. They don't really say, if you do this, everything will be okay. But what they suggest is that there are certain processes that are likely to optimize the combination of public participation and science literacy. And let me start with this first one a little bit, go into some detail. Practice informed consent. If we start from a premise that goes way back to what we talked about earlier in the course about democracy and public policy, that people do have a need to know the consequences of decisions that affect their lives. What we have to do is to provide some means through the policy process of informing them of those consequences. Again, it's not probabilities. It's not talking in statistics. It's talking about scenarios. What kinds of things are likely to happen if we do X, Y, or Z? Or if we don't do X, Y, or Z? What are the consequences? Information needed for informed consent has not always been provided by agencies. Sometimes the law doesn't permit the sharing of this information. So maybe we have to reform the law itself. And we have to make the information understandable. Again, this gets us to translation and transformation. What we have found is that when information is explained in a way that actually responds to what people want to know, not how contaminated is the soil, but what will happen to my kid if he eats the dirt? Because kids eat dirt. You will. That's a parent's question. That's not a science question, maybe. But it is a science question. This is the kind of information that people want to know about. It has to be made understandable. A lot of the risk communication studies that have been done over the past 20 years show us pretty categorical that this is the way you overcome resistance to various societal risks, and how you get the approval of the public in terms of options to clean up sites. In fact, very rarely will people resist a decision by government to clean up contamination if they're told how the process will work and what it will actually result in. But it has to be understandable. I've done some research on this. I think it shows that pretty well. You have to communicate risks effectively. Again, I come back to that word risk, because so much of what we're talking about is risks. Know your audience and talk to them, not at them, using non-technical language. Mark Rashevsky, Roger Kasperson, Paul Slovic. Slovic is a social psychologist who studies public policy. Roger Kasperson is a geographer by training who's taught and done research on regional planning issues for many years. And Mark Rashevsky is a political scientist who studied technology. And basically, this is something they all talk about. This is a very, very important set of challenges. Acknowledge uncertainties, and acknowledge that people worry about consequences, not probabilities. This is something we need to do. Again, coming back to the example of genetically modified or genetically engineered foods. There may be trade-offs. There may be things we don't know about the consequences, but we just have to lay what we know and what we don't know out there and let people decide. And of course, be prepared to always revisit. This gets to the adaptiveness, to revisit a decision if it's wrong. And then I want to spend a few moments on this last issue about, this is really the citizen science issue. This gets us back to the transformation and the translation. We have to provide a forum for people from different ways of life. This is what we really mean, or should mean, by public participation. It's not just having the public in their own isolated advisory board, and then the scientists in their own isolated advisory board, and then whoever else in their own isolated advisory board. You need to provide a forum in which the analysts, the policymakers, and citizens are able to identify a common idiom, common language for debate and discussion. This gets participants to acknowledge that there are alternative points of view on any issue. Anybody disagree with it? There's only one. Just asking, see if you're right. Alternative points of view that have to be heard if debate is to move forward. Peter Haas, who has studied this issue in the context of global environmental problems, calls this an epistemic community. It's a fancy term, but a simple translation of an epistemic community is bringing together people from different ways of life, but providing a common language. Again, it's the citizen science model. Risa is an example of this. Haas talks about another example in his writings, a couple of other examples, but one of the examples I really find fascinating in his research. He's applied this model to international environmental problems. And he argues that many, many years ago, the demise of the use of chlorofluorocarbons that were depleting the Earth's ozone layer came about because of this precise process. What you had was a lot of scientists, including our own Sherry Rowland, who had been doing a number of studies for years saying this is a real problem. And of course, he was roundly condemned by the CFC industry. Not a very popular person. As we began to move ahead towards some sort of international regime to regulate these ozone-destroying compounds, what Haas said finally turned the ship around was that the United Nations, with the cooperation of major producing countries like the United States and like France and like the UK and like Russia, agreed to create bodies that would examine this problem by bringing scientists together with corporate leaders, together with diplomats who understand the language of international law, together with various non-governmental organizations, and to create an epistemic community, which eventually produced a treaty called the Montreal Protocol, in which everyone agreed that over a certain period of time, they would renounce the manufacture of CFCs and their use. Now, of course, why do you want to bring the corporations on board? They're the ones producing. And if they're going to solve this problem, you're going to have to do what?
Well, they're most likely the ones to produce the alternative, too. So.
They're the ones who are going to have to produce alternative compounds, and they're only going to come on board if they are allowed to collaborate with one another. Right? If it's one company becoming a winner and others becoming a loser, then they're not going to collaborate. And yet, in the meantime, the Earth's ozone layer is in danger. An epistemic community. Questions? Comments? Okay. So where does this leave us? So kind of full circle. These aren't solutions, but they're avenues towards solutions. They are ongoing challenges facing public policy, I would contend. So let me remind you of a couple things. Public policy began, as we saw 10 weeks ago, as a kind of an optimistic enterprise based on the notion, based on the view that societies can engineer, in quotes, solutions to problems. The ancient Greeks certainly believed that, Plato and Aristotle, Montesquieu, French philosopher in the 18th century also believed it. It is also a field, to remind you of some challenges that we talked about earlier in the course that I think tie directly to what we're talking about today. It's a field that has had to face the limitations of organizational democracy and unequal power. You remember the iron law of oligarchy. Organizations are not, by nature, open and democratic. And in fact, the more complex they become, the less democratic they're likely to become. Weber and Auguste Comte on the role of expertise as a source of power remind us that it is also very difficult for organizations that carry out policy mandates to share knowledge and expertise with others. And then finally, the duality, bless you, and the complexities of science and ethics together has also been a preoccupation. Deborah Stone, Beryl Radin have talked about the fact that it's not enough to move forward on policy just with science. There are limitations to what science can tell us. All of the questions we face in public policy, including what we've talked about for the past couple of days in terms of the future, are ethical questions. What role should the state have in dictating what we can or can't do, or what we should or shouldn't do, or how we should or shouldn't use knowledge? We seek to reconcile both science and ethics, I would contend, for 4 reasons. And these 4 reasons, or 3 reasons, that are going to be around, I think, for as long as we study public policy. They're going to be there forever. We do want to evaluate the efficacy of both policy processes and outcomes. We can't evaluate public policy, as we know, unless we consider the ethical implications as well as the scientific implications. We also know that policies have consequences, both for efficiency, improving economic development of societies, as we saw, and also for equity or fairness, burdens, costs, risks, opportunities fall unevenly on different populations. And this is an issue of fairness. And then thirdly, we want to learn, I think, I'd like to think what we're doing is not an abstract science, but is a practical exercise. We want to learn how to design policies to serve society's needs more effectively. That, by the way, is I think what makes public policy different from, say, a pure social science. We're not just interested in explaining or anticipating behavior. We are advocates, or we should be. At least in the broad sense of we want to make things better. And we want to help provide people with knowledge to make things better. And De Mesquita, Ellis, Palin, Weaver, Levin, and Shapiro, I think, show this. So I'll just leave you with this. Didn't have a fourth sub-bullet. Other than if I did, I would simply say that I would come back to the beginning. It's for all these reasons that public policy and the analysis of public policy has to be multidisciplinary. There is no field, not the humanities, not the social sciences, not the natural sciences, not the engineering sciences, not planning. There is nothing that does not or is not embraced by these challenges. And so we're going to be all, I think, working for quite some time on this. So that's all I had. Any questions? Okay. Look forward to your papers.